So now we're going to go ahead and look at 1.4. And 1.4 is more applications. So we're going to look at some money problems. We're going to look at some problems that involve distance. We're going to look at consecutive integer problems. And then we're also going to look at problems that involve angles on a triangle. So I'm going to be using our textbook, and I'm on page 98. And we're now going to look at question 12. So we'll read it, we'll work it through, we'll do 2 of these, then we'll look at some distance problems, some consecutive integer problems, and then finally some angle problems. So let me put question 12 on the screen here so we can see what we're looking at together. Muhammad works at an ice cream shop. At the end of his shift, he counted the bills in his cash drawer and found 119 bills. The total value of the bills is $347. If the bills are 5s and $1 bills, how many of each denomination were in his cash register drawer? So we're going to set this up just like we did the investment problems. Okay, so I'll use dollar signs again to represent the different types of bills. And what we've got is the number of bills and the value of each bill. And then over here, we have a total number of bills. And the first thing that we know is we know that we have 119 bills. So that's going to go here. We've got these bills that are either $1 bills or $5 bills. We don't know how many of each type we have. So we're now going to go ahead and use X to represent the $1 bills. And 119 minus X, that represents the $5 bills, because that is the total minus X again. Now we build our equation based upon the value, total value. And the total value of the money is going to be the number of bills times the value of each bill. So for our first one, we're looking at the $1 bills. So that's going to be just simply 1x, or just an X there. Then we've got $5 bills. So we have 5, and we have 119 minus X. And then what's the total value of all the bills put together? Not the number of bills, the total value. Well, that's 347. So that's the total value. Now we can solve this and we can answer the question. So distribute that 5 through. 5 times 119. Well, that's 595 minus 5x. And that equals then 347. We're going to put the x's together on the left, so that makes it 4x plus 595 equals 347. Move that 595 over. That leaves you then with a minus 4x equals now minus 248. We'll divide by our negative 4. And negative over negative makes it a positive. So now our value of x is going to then be 62. What does x go with? Well, if we go back up and look, x goes with the number of $1 bills. Our question says, how many of each do we have? So for the $1 bills, we have X. So that means we have 62 bills at $1 each. We also need to find the number of $5 bills. So the $5 bills would be 119 minus 62. So that then gives you 57. So we've got 57 bills at $5 each. So we've got our number of $5 bills, and we've got our number of $1 bills. How could you check this if you wanted to? Well, you've got 57 $5 bills, so we'll multiply that by 5, add our 62 $1 bills to that, and we get 347. And that 347 is the total value of all the bills put together. So we know that we did it correctly. So that's an example of a money type of problem. We're going to do one more of these, and we're going to look now at question 16. So I'll put question 16 on the screen so we can see it here. This one's talking about the tickets for production. So for a high school production of Hello Dolly, student tickets cost $5 and non-student tickets are $8. 480 tickets were sold for $2,895. How many of each type were sold? So again, we've got two types of tickets, and we've got a total. And this is going to be our total tickets. Not the amount, it'll be total tickets. So we know that we sold 480 total tickets. So we've got tickets in the value or the price, whatever, however you would like to label these, just as long as you know what's happening. I like to use value, you can use price. So we've got two types of tickets. They're $5 and $8. And just like many of the others, we don't know how many of each one. So we'll call the first one X. The second one is going to be 480 minus X, because that is your total minus X there. Now we can build our equation. Again, we're going to be using total value. And our total value is the number of tickets times the value of each ticket. So for our first one, we'll label this one 1 and this one 2 again. So for our first one, we've got $5 tickets, so that's 5x. We then have $8 tickets. And what is that going to be? That's going to be 8 times 480 minus x. And then we need to know the total value, not the number of tickets, total value. So how much money did they take in for this Hello Dolly production? Looks like they took in $28.95. Now we can solve it. We need to get both of these. So we'll begin by distributing through that 8. Combine like terms and solve it. So that is then 5x plus 8 times that 480. So that's 3840 minus 8x, and that equals 2895. Combined, we get a minus 3x plus 3840. That equals then 2895. We'll move that 3840 over. And now we have a minus 3x equals now 2895 minus 3840. It gives us a minus 945. Divide that by our negative 3. And that gives us x now equaling. Negative and negative makes it a positive 315. We need to make sure that we answer the question. So going back up and looking here, X goes with the $5 tickets. So we've got 315 tickets at $5 each. So those represent the student tickets. And what about the other one? Well, the other one is 480 minus 315. That gives us then 165. So what do we know that now? We have 165 tickets at $8 a piece. So that is how you would solve these type of questions. So that's what we've got there. Moving on, we're going to talk about distance and how these distance problems work. For the distance problems, they can either add, subtract, or equal. So we have to watch the direction of these distances. So now we're going to look at our distance problems. And when we talk about distance problems, if they're two cars going in opposite directions, like this, it's addition. If they're going towards each other, like this, it's addition. If they're going north and south, it's addition. So these are all addition. If they overlap, then it's going to be subtraction. So this would be subtraction because we have overlap. So anytime they overlap, it's subtraction. And this would be something like two people run a race. One is going faster than the other one. The distances apart would be found by subtraction. And then finally, we have the equals. And where do we have the equals? Well, we have the equals when the distances are the same. So that might be something like going to school and coming back home. If it's 10 miles to school, it's going to be 10 miles back home. Those should be equal to each other. So these are the three different scenarios that we may encounter. So we're going to look at a few of these. The textbook uses tables. I like to use a diagram. I think it's a little bit easier. We build our equation based upon the distance. So very, very similar to the pure and also to the interest from the questions out of 1-3. So let's work with a few of these. I'll put these on the screen. Again, I'm on page 98. And we're going to look now at question 22. We're not going to worry about the table because we're going to draw a figure instead of a table. So question 22, let's make sure we can see it on the screen. A train leaves Kansas City, Kansas, travels north at 85. Another train leaves at the same time, travels south at 95. How long will it be before they are 315 kilometers apart? So these are kilometers per hour. So let's draw our diagram here. So we're going to start in Kansas City. And we've got a train going north and we've got a train going south. Each of these has a rate and a time. And we're going to start right here in Kansas City. So one's going north, one's going south. What do we know about these trains? Well, we know one goes 85 going north. That's kilometers per hour. The other one travels a little bit faster at 95. What we don't know is the time. So I'm going to use X because they leave at the same time. And we know our total distance is given in the problem. And our total distance that these need to travel is 315 kilometers. So that's going to be our total distance. And we'll label these as train 1 and train 2. Now, they're going in opposite directions. They do not overlap, so that means this problem is going to be addition. So they're going to add together. Our distance is found by taking the rate of speed times the time. Whenever you drive a car, you've got three parts to that. How far you're traveling, so how many miles or how many kilometers, you've got your rate of speed. How fast you're going, and then you've got how many hours or minutes it took you to get there. And rate times time gives you the distance. So for our first one, we've got 85x. For our second one, we've got 95x because they multiply together just like before. And what do they equal? 315. We can add these together and easily solve this. So now we have 180 equals 315. We'll divide by our 180. That gives you then x equals now 1.75. And there are a couple of ways you can write your answer. You can write that as 1.75 hours. You could write that as 1 3/4 of an hour. Or you could write that as 1 hour and 45 minutes. Now, how did I get the 45 minutes? Okay, so for this one, we've got 1 hour and 45 minutes. And how did we do that? Well, we got that by taking the 0.75, which is our remainder, times the 60 minutes in an hour. And that gave us then 45 minutes. Any of these would be an acceptable answer. Probably the preferred answer would be 1 hour, 45 minutes. So in 1 hour and 45 minutes, these trains should be 315 miles apart. Now we'll do another one. Question 25. Charmaine took 3.6 hours to drive to her mother's house on Saturday morning for a weekend visit. On Sunday night, traffic was heavier, so it took her 4 hours. Her average rate of speed on Sunday was 5 miles an hour slower than on Saturday. What was her average rate on Sunday? Now, when we look at this problem, what do we know? We know they should be the same. Because if it's 20 miles to her house, it's going to be 20 miles back home. So when we label these they're going to equal. So our vectors look like this. These lines are called vectors. And this will be Saturday. And this will be Sunday down below. Now, each of these has a rate and a time again. So when she drove to her mother's house, it took her, on Saturday, 3.6 hours to get there. On Sunday, that was 4. These should, again, equal each other because those distances should be the same. Now, what about our rates of speed? Well, we don't know. But we do know on Sunday, her rate of speed was 5 miles an hour slower. So on Saturday, we don't know the speed, so we're going to call that x. On Sunday, we don't know the speed, but it's slower, so that's going to be x minus 5, because it's 5 miles an hour slower. Now we can build our equation here. And again, the distance is going to equal the rate times the time. And these should equal, so Saturday should equal Sunday. So what do we have for Saturday? Well, Saturday, we have 3.6 times x. That's your rate times your time. What about Sunday? Sunday, we have 4 times x minus 5. We now have the information that we need to finish this out. So we'll distribute that 4 through. So go ahead and distribute that 4 through, and we get 3.6x equals 4x minus 20. We'll move that 4x over. Careful with your decimals. So watch the decimals there. That gives you a minus 0.4x equals a minus 20. We'll divide by our minus 0.4 on each side. And that leaves us then with x equaling 50. What does the question want? It says, what was her average rate on Sunday? So make sure we answer the question. So Saturday's rate of speed was x. And so Saturday's rate of speed was 50 miles per hour. But we don't want that. We want the Sunday one. And what about Sunday? Well, Sunday was 50 minus 5 because it's slower. So that makes it then 45 miles per hour. So she traveled at 45 miles per hour on Sunday. And that's going to answer that question. Moving on, we'll look at one more of these. We'll look at question 28. The previous one, by the way, just so we know, the previous one was question 25. So this was question 25. Now we're going to look at question 28. So we put 28 on the screen here. On an automobile trip, Laura maintained a steady rate for 2 hours. Rush hour traffic slowed her by 25 miles per hour for the last part of the trip. The entire trip, a distance of 125 miles, took 2.5 hours. What was her rate during the first part of this trip? So what we've got is we've got 2 parts to this trip. So she's traveling along for the first 2 hours. So for the first 2 hours, she maintained a steady speed. And so that means for the first part of our trip, we have a time of 2. Then she hit rush hour traffic, and her rate was slowed by 25 miles per hour. We don't know the rate of speed of the first part of this trip, so we'll call this x. For the second part of this trip, it's slowed by 25. So that means it's going to be x minus 25 then. Okay, so rush hour traffic slowed her rate by 25 miles per hour. Now, we know our total time, and we need to make sure we know this, is 2.5 hours. So for our time, we've got 2 hours here. So that means our time in the rush hour traffic was a half of an hour. You could use 0.5 if you want, but I'm just going to use a half. Now we can find our distances here. And we know these should add together. So let's go ahead and build our formula. Again, distance equals the rate times the time. So for our first one, rate times time is 2x. For our second one, we've got 1/2 times x minus 25. And then we need our total distance, which is given in the problem to be 125. So this is your total distance. So that's what we've got there. Distribute that half through, and then we'll clear our fractions. So now we've got 2x plus 1/2 x minus 25 over 2, when we distribute, equals 125. We're going to clear our fractions by multiplying everything by 2. So that's going to clear out all of our fractions. 2 times 2 makes it a 4x. 2 times a half is a single x. 2's cancel, leaving you with a minus 25. On the right, 2 times 125 is 250. Combining, we now have, it looks like 5x minus 25 equals 250. We'll add that 25 to each side. And now we have 5x equals 275. We'll divide by our 5. And we have now x equaling 275 divided by that 5, 55. Right, so what do we want to find here? Make sure we know what we want to find. We want to find the rate during the first half of her trip. So that's here. Okay, rate during the first half then is x. So that first rate is going to be 55, and this is miles per hour. And that would be the answer to this question. Next, we're going to look at angles and how these angles work. We're going to look at triangles, and we're also going to look at straight lines and 90-degree angles. So let me get these labeled here. So in order. Start another type of question. We're still in 1.4. And we're going to start with triangles. Now for triangles, what do we know? We know that all the angles in a triangle sum to 180. So again, we're still in 1.4. And we know the sum of angles in a triangle is 180 degrees. So we know when we add up all the angles in a triangle, it's going to add up to be 180. So we'll do 2 of these, and then we'll look at some different angles. So I'm going to draw the diagram up from question 29, and this is on page 99. So I'm going to go ahead and draw that triangle up. And we've got 2x minus 120 here. We've got 1/2 x plus 15 here. And then we've got x minus 30 down below. These are going to sum to 180. So we're going to go ahead and add these up to 180. So our equation is then 2x minus 120 plus 1/2 x plus 15 plus x minus 30 equals 180. We can go ahead and combine, and then we'll clear our fractions. So let's go ahead and add some things together. So it looks like we've got 3x plus 1/2 x. And then we've got 120 that's negative, 30 that's also negative, and then 15 that's positive. So that makes it a minus 135. And that equals then 180. I'm going to go ahead and add that 135 to each side to move it over. We've got 180 plus 135 gives you then 315. We could have cleared the fractions out earlier. I'm going to clear them out now. So to clear out the fractions, we'll multiply everything by a 2. You could have also used 0.5, but I usually work with the fractions. So that's going to be 3 times 2 is a 6. Half is gone, so that makes it an x. And then don't forget the right-hand side, 315 times 6. Or sorry, 315 times 2 there. My mistake. Is 630. So that gives me 7x equals 630. Divide by our 7. Now we've got part of our answer, not our final answer. We only have part of it. Okay, so we found x. Now, x is not our answer. To get the final answer, what we're going to have to do is plug that value back in. So let's redraw our diagram quickly, and we'll fill it in. Okay, so we've got 2x minus 120. We've got 1/2 x plus 15. And we've got x minus 30 here. You need to find all 3 angles. So the first one is going to be 2 times 90 minus 120. So that's 180 minus 120 gives you 60 degrees. So there's that one. Next, we've got 1/2 times 90 plus 15. Well, half of 90 is 45, and 45 plus 15 gives you then 60 degrees as well. And the last one is 90 minus 30, which that is also 60 degrees. So what are our answers? Our answers are 60 degrees, 60 degrees, and 60 degrees. This is called an equilateral triangle because all of them are the same. So they're all 60 degrees. But do not just write down 90 because 90 is not your answer. You've got to take that 90 and plug it back in to get all the angles. We'll do one more of these quickly, and then we'll move on to another type of angle. 34. All right, so question 34. I know my triangle looks a little bit different, but that's okay because we've got x plus 10. We've got x plus 4. And we've got 12x minus 30. And again, my triangle may not look exactly like theirs, but we're going to solve it the same way. What do we know? We know they add up to give you 180. So that's all the angles added up there. So how many x's do we have? Well, if we add them together, it looks like we've got 14x. Adding the numbers together, we've got 10, 4, and a minus 30. So 10 and 4 is 14. Subtract off that 30. Watch your signs. That's going to be a minus 16. That equals 180. Add your 16. This one's actually a little bit easier. And that gives you then 14x equals now 196. Divide by your 14. And x now comes out to be 14. 14. So that's not our answer. Okay, how do we get our answer? Well, we need to go back and plug them in. We've got it up here, so I'm just going to leave it here. So what do we know? We know this one is going to be 14 plus 10. And 14 and 10 makes it 24. So that's one of them is 24 degrees. The other one is 14 plus 4. So that's 18 degrees. And then we've got our last one, which is 12 times 14 minus 30. That then comes out to give you 138 degrees. So now what's our final answer? Or answers? Our final answers are 24 degrees, 18 degrees, and 138 degrees. And we know we did it correctly. How? We add them together. What should they give you? 180. So 24 plus 18 plus 138. See, that gives you 180. So we know then that we did it correctly. So these are going to be our answers right here. 24, 18, and 138. So for triangles, they need to sum to 180 degrees. Here are some other angles that we need to keep track of as well. These are called complementary angles, and they sum to 90. So complementary angles, sometimes called right angles, these are going to sum to 90. So if you have something like this, this is going to sum to 90. So it's going to work the same way as the triangles. It's just that instead of adding it up to be 180, we add it up to be 90. Supplementary are straight lines. So supplementary angles, they sum to 180 degrees. So this is an example of a supplementary angle. See, these would sum to 180 because they form a straight line. And we've got one more type to look at, and that's vertical angles. So we've got complementary, sum to 90, supplementary, sum to 180, and we've got vertical angles next. And we'll do an example of a vertical angle. The vertical angles equal each other. The vertical angles, what they do is they form an X. And here's an example of a vertical angle. This is a vertical angle here. And the left equals the right. And the top is going to equal the bottom. So that's what we've got for these. We're going to look at question 39. Oh, sorry, 36, my bad. So 36. And this again is on page 100. So on page 100, question 36, these are vertical angles. So that means they're going to equal each other. These are actually a little bit easier than the triangle ones. So we've got 9 minus 5x here. And we've got on the other side 25 minus 3x. So what do we know? We know they form an X. These are vertical angles. So those equal. So our equation is simply then 9 minus 5x equals 25 minus 3x. And now we can simply solve it. We'll solve it, we'll find our x, but x is not going to be our answer. We have to take it and plug it back in. So I'm going to add that 3x over and move that 9 over at the same time. So you should be comfortable with these now, hopefully. Subtracting, you will get a minus 2x on the left, and 25 minus 9 makes it then 16. Divide by your negative 2, and x equals a negative 8. Again, that is not your answer. How do we find our answer? What do we need to do? We need to take the negative 8 and plug it in to both of them. They should be the same. So we've got 9 minus 5 times a negative 8. Double negative makes that positive. So that's going to be 9 plus 40, which is then 49 degrees. What about the other one? Well, the other one is 25 minus 3 times a minus 8. Double negative makes it a positive 24. And that also gives you then 49 degrees. So what are our answers? Just so we know, our answers are going to be on this question 49 degrees for both. So that's how we work that one out. So that one would have an answer then of 49 degrees. One more type of question for this section to look at is integers. So we're going to look at consecutive integers. And consecutive integers are back-to-back numbers. So consecutive integers are back-to-back numbers. So consecutive integers would look like 5, 6, 7, 8, 9, and so on. or they could be even things like addresses. So 3600, 3601, and so on. So 3602. Those are consecutive integers, gap of 1. What about odd or even? Well, if it's an odd or it's an even consecutive integer, that would be things like 4, 6, 8, and 10. Those are even. Odd would be like 9, 11, 13, and 15. These have a gap of 2. Okay, so even or odd, they have a gap of 2. Plain consecutive numbers, they have a gap of only 1. So these are going to have a gap of 1 here. When we talk about consecutive integers, we need to see how we would label them in an equation. And normally we use 3, maybe 4 consecutive integers at the most. So consecutive integers again, these are back-to-back numbers. The first one we always call x. Second one is x plus 1. Add 1 each time. Third one is x plus 2. Fourth one would then be x plus 3. So that's your pattern for consecutive integers. Now what about even or odd? Well, even or odd consecutive integers they have a gap of 2. So my first number would be x again. Second number is x plus 2. Third number, x plus 4, adding 2 every time. And your fourth number would then be x plus 6. So these we add 1 for plain consecutive integers. For even or odd, we have to add 2. We'll do probably 3 of these, and then that's going to finish our lecture for today. So let's look now at question 42. And this is on page 100, number 42. Find 3 consecutive integers such that the sum of the first and twice the third is 39 more than twice the second. So first thing we work with is the integers. Now we know we need 3 of them, and they're consecutive. No even or odd, so that means my gap is 1. So the first one is x, second one is x plus 1, third one is x plus 2. Now let's read this again. Find 3 consecutive integers such that the sum of the first and twice the third. So the first plus twice the third. Remember, is means equals here. So we need an equals for that is 39 more than twice the second. So that's going to be 39 plus 2 times our second integer. Always write it out like this, and we plug our values in. So we know our first number is x. We need our third number here. Our third number is x plus 2. That equals 39 plus 2 times our second number, which is x plus 1. We can distribute through now, and we can solve it. So let's go ahead and distribute that 2 through. And over here as well. Combine and get our final answers. So we now have x plus 2x plus 4 equals 39 plus 2x plus 2. Combine, 3x plus 4 is on the left. On the right, we've got 2x, and adding together makes it 41. And we add those together. So it looks like we're making progress here. We've got everything combined. Now we just move that 2x over and move that 4 over as well. So that leaves us then with x equaling now 41 minus 4, that makes it 37. Now, when we work these out, we need to make sure we get all 3. So make sure you get all 3 of these integers. So we have 37. The next one's 38. And the last one is 39. So those are our 3 consecutive integers. Now let's do another one. This one's going to be even. So 48. Question 48 says, find 3 consecutive even integers such that the sum of the least integer and the greatest integer is 12 more than the middle. So we need 3 even integers. So these are even. So that means we have a gap of 2. So my first one is x. Second one is x plus 2. Third one, we'll move this up here, is going to be x plus 4. This is the least. This is the middle. And this is the greatest. Now we build our equation, solve it, and we get our solution. So we need 3 consecutive even integers. That's right here. We've done that. Such that the sum of the least and the middle. So we're going to add these together. Least and the middle is, oh, sorry, wrong question here. My mistake. I was looking at 47. 48 says least. Okay, if we read it correctly, such that the least and the greatest. So least and the greatest here. Okay, sum of the least and the greatest is means equals 12 more than the middle integer. So that's going to be the middle plus 12. So that's our equation now. So we've got the least and the greatest summed together to give the middle plus 12. Now we can finish it. We know our least is x. Our greatest is x plus 4. Middle is x plus 2. And then we've got a plus 12. So combining, that's 2x plus 4 on the left equals then x plus 14 on the right. Move things around, so move that x over, move that 4 over. And now we have, it looks like x equaling 10. So move these over, we get x equals 10. So what are our 3 integers? We have to get all 3. Don't just stop here. We need to get all 3. Well, they would be 10, 12 would be the next one, and 14. So those are our 3 consecutive even integers. I think we've got enough time to do one more. That will finish up then 1.4. So let's do one more. This will be an odd one. And we're going to look now at question 50. Find 3 consecutive odd integers such that the sum of the least and the greatest is 13 more than the middle. So very, very similar to the last one. What do we know about odd integers? Well, they're like even, they have a gap of 2. So for the odd integers, our first one is x, our second one is x plus 2, and our third one is going to be x plus 4. Now, what does it say here? It says the sum of the least and the greatest is 13 more than the middle. So the least plus the greatest is, again, means equal. Middle plus 13. Okay, our least is going to be x. The greatest will be x plus 4. The middle is our second one here. That's x plus 2. And then we've got a plus 13. Combining, that's 2x plus 4 equals x plus 15. We'll move our x over, and we'll move our 4 over as well. Now we have x equaling 15 minus 4 is 11. So what are my 3 numbers? You have to get all 3 for full credit. Our answers would then be 11, add 2 makes it 13, add 2 makes it 15. So these are our 3 integers, and that finishes up our lecture. So what's our homework? Well, our homework for next week is going to be 1.4, and you should be able to do them all. So that's going to be our homework. Hopefully next week we'll have class. We can go over some of these questions out of 1.4 at the beginning of next class period. And then we'll be able to do 1.5 and 1.6 next week.